Okay, let's do mixed function fractions. Let's start with 6 over 4, which is improper fraction, multiplied by 1 over 6. With multiplication, super easy, goes left to right, numerator to numerator, denominator to denominator. 6 times 1 is 6 over 4 times 6 is 24. This is not simplified. Both numbers are even, so at the very least, they are both divided by 2. But we notice that 6 is a factor of 24, and 24 is a multiple of 6. So they can both be divided by 6. So to break this fraction down, we divide by 6. 6 divided by 6 is 1. And 24 divided by 6 is 4. Next one is addition, and it's a little bit more difficult because the denominators must be the same. So in this instance, they are already the same, so that makes it very simple. In addition and subtraction only, the denominator remains the same. The number do not add, do not multiply, comes over exactly the same. Only the numerators or the top numbers get added at this point. 2 plus 9 is 11. 11 and 12 have no common factors. So this is its lowest form, simplest term, and simplified. The next one is subtraction. And again, both of denominators are the same, which is very helpful because they need to be the same. So the denominator remains the same. It is neither added nor subtracted nor multiplied. It comes over exactly as it is. And the only numbers that change are the numerators. And 5 minus 3 is 2. The next function problem that we're going to do is division. Division is a little bit different. The first number stays exactly as it is, 5 over 9. And since we can't divide by division, dividing by division is actually multiplying by a fraction or division. So what we need is what's called the reciprocal. So 5 over 9, and we take the reciprocal, which just means that we flip it, and now it is a multiplication problem, no longer division, and it is 9 over 5. So 5 times 9 is 45, and 9 times 5 is 45. So the answer to this one is 1. Then we have one more division to take care of. Again, never ever change the first number. So that turns into 7 over 9, remaining exactly the same. We take the reciprocal of the next number because this is going to turn into a multiplication problem. So it is no longer 4 over 2 or numerator 4 over denominator 2. It gets flipped. So we want that to be 2 over 4 with a 2 in the numerator position and a 4 in the denominator position. Just like with the rest of the multiplication, it is straight across. 7 times 2 is 14, and 9 times 4 is 36. Now, in looking at these two fractions, we notice that they both end in even numbers. So at the very least, they can both be divided by 2. So that's what we're going to do. 14 divided by 2 is 7, and 36 divided by 2 is 18. There are no common factors between 7 and 18, so this cannot be reduced any lower. All right. So as we move along to now number 6, it is again an addition problem. Already we have a common denominator, so we don't need to change anything with these. So in addition and subtraction, our denominators remain the same if they are like, and so that happens to be 3. And then we add the numerators. 10 plus 7 is 17. This answer is an improper fraction, meaning that the numerator or top number is larger than the bottom number. So the way we do that is the numerator goes inside the division doghouse, and the 3 is on the outside, right? So this is a division problem, and this is what it looks like when we divide. 3 goes into 17 5 times. 5 times 3 is 15. Then we subtract from the 17 inside the doghouse, leaving us with a remainder of 2. We have 2 pieces of 3 possible, so that is now our new fraction. We have 5 whole pieces and 2 remaining pieces of 3 that we could have. So that is the new fraction. It is called a mixed fraction, going from improper fraction to a mixed fraction. All right, number 7. We have 5 over 5. Most of you would recognize any number over itself is 1. So honestly, we don't really have to do all the function. We can recognize that this is 1, telling us that 5 over 5 is 1, right? That our answer would be 9 over 6. But just for fun, we're going to do the math. 5 times 9 is 45. And 5 times 6 is 30. So we could, recognizing that both end in either a 5 or a 0, we could reduce it in this form, or because it's an improper fraction, we could turn it into a mixed number. So I always like to work with smaller numbers. So the first thing I'm going to do is look at it, and I know that both of these are divided by 5, but I'm going to take it a step further, knowing that 2 15s equal 30 and 3 15s equal 45. I'm going to divide 15 out of both of these, and I will end up with 3 over 2. This division is much more simple. So that equals the numerator 3 inside the doghouse with my down number or denominator on the outside of the doghouse. 2 goes into 3 one time. 1 times 2 is 2. Subtracted for 3 with 1 left over. So I have 1 remaining piece of a possible 2. So that ends up having 1 whole piece, because that's at the top here, 1 remaining piece out of a possible 2. Number 8 is subtraction, and again, it's very handy that we have the same denominators. So the bottom number comes over just as it is in addition and subtraction, and then we subtract 2 from 8, which is 6. There are no common factors between 6 and 7, so this is reduced to its lowest form, simplest term. It is simplified. All right, number 9. So in number 9, we have 11 over 6 and 4 over 6. Again, it's an addition problem and the denominators match, so we don't need to do any type of conversion there. Our denominator remains the same as 6, and we only add the numerators. In addition and subtraction, the denominator is remains the same. 11 plus 4 is 15. Again, we have an improper fraction because the numerator should not be larger than the denominator. So we put our 15 inside the doghouse and our 6 denominator on the outside of the doghouse. 6 goes into 15 2 times. 6 times 2 is 12. And 15 minus 12 gives us a remainder of 3. So our answer is 2 whole pieces and 3 of a possible 6. Remainder 3 over denominator 6. We have one more step to go because this is not completely simplified. Both the 3 and the 6 have a factor of 3. So this can be converted further to 2 over 1/2. Then our last one is again division. When you divide fractions, you need to have a reciprocal on the second number only. Never change the first number. The first number must remain the same. So 2 over 9 remains the same. We are going to turn this into a multiplication problem. That means that we have to take the reciprocal, so we flip this where 2 is the denominator here, becomes the numerator here, and the 9, that's the numerator here, becomes the denominator. We multiply straight across, numerator to numerator. We have 4, and denominator to denominator is 81. All right, in looking at these numbers, do they have any common factors? Can 81 be divided by 2? No, it ends in an odd number. Can 81 be divided by 4? No, in looking at that, we know that 80 is a multiple of 4, but not 81. So this is as simplified as it can get, 4 over 81.